Okay, since we introduced radians, let's go ahead and take a look at how to convert to degrees, the radians, degrees, and back and forth. And the formula that I've always memorized is this. And let me explain how that works. Say if you have some angle, and I'm just going to say some angle right here, theta. So we're looking at proportions here. Is that angle in regards to 360 degrees, okay, which is the number of degrees in a circle, is going to be the same ratio in radians as 2 pi is to 1 turn around the entire circle, as we learned in the last video, okay? So anytime that we want, if we have degrees, we can plug in the degree measure and then solve for radians. Or we can go backwards. If we have radians and we want to solve for degrees, we plug radians in and then solve for degrees, just by doing some the cross multiplying and whatnot. So let's do an example real quick. 135 degrees. So I know that is going to be a degree measure, and so I want to put it right here. So I'm going to say 135 degrees is to 360 degrees, as theta r, which is theta in radians, is to 2 pi. So after I go ahead and do some of the crisscrossing here, well, basically what I'm going to do is that I'm going to solve this thing out. And we're going to solve this out by doing some crisscrossing. But I want to, on the left-hand side, I want to reduce that fraction, which reduces down to 3/8. So I get 3/8 equals theta r 2 pi. So what I want to do now is I want to cross multiply. Okay, so I get 3 times 2 pi, which is going to give me 6 pi, and 8 times theta r, which is going to give me 8 theta r. Okay, and then I want to know what theta r is. That is that radians, so I divide each side by 8. Okay, those go out, and I end up with 6 pi over 8, which is going to be the same as 3 pi over 4 radians, okay? And so, that said, is that 135 degrees equals 3 pi over 4 radians, okay? So just to go ahead and show you, about 135 degrees is going to be right here, and 3/4 of the way to pi is going to go ahead and be the same radial degrees, okay? Or I would say radial measure. All right, so let's look at the next one and see how a negative sign could go ahead and impact it. Okay, so for the negative 60, I plug in up top because that's the degrees, and I want to know how many radians that is going to be. So that said is that I'm going to reduce the left-hand side. And from here, that reduces down to, pardon me, 1/6. And I am going to cross multiply. So I end up with a negative 2 pi, negative 1 times 2 pi. And then 6 theta r is going to go ahead and equal that right-hand side. I divide by 6 on each side. Those go out. And I got a negative 2 over 6, that's going to give me a negative 1 pi over 3 radians, okay? And we don't need the negative 1 there. I just put that there to show the cancellation, so it's actually going to be a negative pi over 3 radians, okay? So that's how you do that guy. Okay, for this next one, we want to get 15 degrees, okay? And 15 degrees is going to go ahead and be on top right here. And we want to get radians, so I'm going to reduce the left-hand side. All right, which will look like that. I divided 15 in the top and the bottom to simplify this fraction right here to get this guy. And then cross multiply. So I get 2 pi equals 24 theta r. Divide each side by 24, and that's going to give me 2 pi over 24 equals theta r. And then this is going to cancel. 2 goes in the 2 once. 2 goes in the 24 12 times. So theta r is going to equal pi over 12. Okay, so that is going from degrees to radians. So let's take a look at going from radians to degrees. In this case, I have 4 pi over 3, and I want to know how many degrees that is. So I'm going to plug that in to theta r and solve for theta d. So this is the way that I set this thing up. Okay, now on the right-hand side is going to be a little bit tricky if we have a fraction. So let's look at the setup up here, okay, and how to simplify that out to make this problem easier. And so if I have 4 pi over 3 divided by 2 pi, that's the same as 4 pi over 3 multiplied by the reciprocal of that, okay? And we can visualize this out as the pi's going out, right? And 2 goes into doing a cross cancellation. 2 goes in 2 once. 2 goes in the 4 twice. And so I end up with 2/3 on the right-hand side. And so I can rewrite this as theta d over 360 equals 2/3. Now, I do some of this stuff, which is going to cross multiply. So I end up with 3 theta d equals 2 times 360, which is 720. And then divide each side by 3 to get theta d is going to equal 240 degrees. Okay? So basically what you're doing is the exact opposite of what we were doing over here, is that we're given a radian measure and we're trying to go to degrees. Okay, so let's find out what the next ones are real quick. Okay, for a negative 3 pi, I'm going to go ahead and plug this in, and it looks like the pi's are going to cancel out. Okay, so I'm going to get theta d over 360 equals a negative 3 over 2. Let's do some cross multiplying, and I get 2 theta d equals, and I'm going to get a negative 3 times of 360, which is going to give me, it's going to give me a negative 1080. And then I'm going to divide each side by a 2. Okay. And that degree measure is going to go ahead and be a negative 540 degrees. Okay. And so, yeah, let's go ahead and take a look at the last one for good measure, and then we'll have plenty of examples to try this on our own. Okay, so we have theta d over 360 equals 5 pi over 8 divided by 2 pi. So let's go ahead and knock this part out up here. That's like 5 pi over 8 divided by 2 pi, which is 5 pi over 8 multiplied by the reciprocal, because that's how we do the compound fractions. These are going to cancel out. And so multiplying straight across, we have on the right-hand side 5 over 16. And so when we rewrite this, we're going to get theta d over 360 equals 5/16. Let's cross multiply and see what happens. Okay, so 360 divided or multiplied by 5 is going to give us 1800 equals 16 theta d. And now we have to divide off 16 on each side. And at the end of the day, I believe that's going to give us theta d equals, or the amount of degrees that 5 pi over 8 equals is going to be 112.5 degrees. Okay, so this is a standard way how we go back and forth to converting from degrees to radians and radians degrees. Okay, so let's go ahead and get this mastered with some practice, and then I will see you in the next video to push this concept further.